Hi guys, welcome to our channel Shubhada Group of Education Sirsi. You are watching Satish's physics videos for CET and NEET. Look at the problem from current electricity. In the given circuit, the voltmeter records 5 volts. The resistance of the voltmeter in ohms is. Okay, so this is a conceptual based problem here. See, as we know that this is 10 volt, correct? And here it is 100 ohm, and this is what 50 ohm is given. Okay, so assume that it has it is reading 5 volt, as well as, let me say, this is the R is the voltmeter resistance. Okay, see, as the supply is 10 volt here, 10 volt, this is what 10 volt is given. Suppose it is reading how much it is. It's given that 5 volt is given, correct? So it has to share the plus 5 volt. Okay, which one? This 100 ohm resistor, or the voltage drop across this 100 ohm resistor must be 5 volt. Okay, as it is there in the parallel here. Okay, so this is possible only when the R is going to be how much? The R is going to be 100 itself, 100 ohm itself, because just I am using trial and error method here. Since this 100 ohm as well as if it is 100 ohm, they are connected in parallel, right? So at that time, 100 into 100 divided by 100 plus 100, 100 plus 100, that is what R equivalent must be equal to R1 R2 divided by R1 plus R2. This is what we have studied, right? So according to this one, this is what going to be how much? This is going to be 50 ohm here. Okay, or else when they connected in parallel, and at the time R by 2, there are two resistors connected in parallel. So that's the reason why this must be 100 divided by 2, that is what 50 ohm here. Okay, suppose if it is 50 ohm, the combination is 50 ohm. If it is 50 ohm, here it is again, it is 50 ohm here. So at that time, this 10 volt will be divided equally, correct? That is the reason why it is 5 volt, and this must be what? It is also sharing the plus 5 volt. So that law of conservation of energy. Okay, this is successfully applied here. So that's the reason why R is going to be how much? 100 ohm. If R is going to be 100 ohm, the equivalent resistance is going to be 50 ohm. So this 50 ohm equally shared, or they will take the equal parts from 10 volt. It is what? 5 volt as well as 5 volt. So that's the reason why this voltmeter reads the 5 volt as the reading. Next problem. So in the adjoining circuit, okay, the battery even has an EMF of 12 volt and 0 internal resistance, while the battery E has the EMF of 2 volt. Okay, so if the galvanometer G reads 0 here, okay, so galvanometer G reads 0 in the sense there is no flow of current, electric current I equal to 0, we can say, through the galvanometer here. Okay, so that is the condition we need to take here. Then the value of the resistance X is clear. So I am finding two loops here. So let me first loop and second loop here. Let me apply the Kirchhoff's voltage rule for the first loop. Okay, so for that what I do is, okay, so what I do is, it is plus minus. Let me take some current I1 is flowing here. Let me take I1 is flowing here. Okay, same current as I equal to 0 here. So this is, I can take I1 that must be flowing here also. Okay, so let me take the Kirchhoff's voltage rule. So minus E1 plus 500 times I1 plus X times I1, that must be equal to 0. Okay, so E1 is going to be how much? So E1 is 12 volt minus 12 volt plus 500 I1 plus X times I1 is going to be 0. This is the first equation. Let me take. Let me apply the Kirchhoff's voltage rule for the second loop now. Okay, so as the current I is 0 here. Okay, current I is 0. So therefore plus E minus X times I, that must be equal to 0. It implies E is how much? So E is given as 2 volt here. So 2 is equal to Xi. So let me take it as equation number 2 now. Okay, I will substitute the value of Xi in the first equation, so that I will get 12 plus 500 times I1 plus Xi. Xi is how much? 2 now. That is going to be 0 here. Correct? So this is what we have studied here now. I hope that it is clear to everyone. This is minus 12, right? It's minus 12. Okay, so minus 10 plus 500 I1, that must be equal to 0. It implies I1 is going to be 10 divided by 500. Okay, so that is what? 1 by 50 ampere. Okay, 1 by 50 ampere is the current. I1 is 1 by 50 ampere. So that's the reason why from equation number 2 I can say, so from equation number 2 I can say that 2 is equal to xi. X into I is how much? 1 divided by 50. It implies 1 divided by 50, right? 1 by 50. So therefore x is equal to 50 into 2. That is what? 100 ohm. So x is equal to 100 ohm. So option B is the right answer for this particular question. 2 is equal to, go to the next problem. The magnitude and the direction of the current in the circuit shown will be. Okay, so again this is also the problem from the Kirchhoff's voltage rule or loop rule you can use here. So as you know that, let me apply some current I is flowing as they are in series, same current flows. So I, 1 into I is I, so minus 10 volt plus 4 volt plus 2 times I plus 3 times I, it must be equal to 0. The Kirchhoff's voltage law for this loop. Okay, I have given how to use, or I have introduced how to use the Kirchhoff's voltage rule in a loop for the paid members. Okay, so try to go through that also. Okay, those who are watching our free videos, just try to learn it from any book like H.C. Verma or Halliday and Resnick and all. Okay, so here suppose if I simplify it, so I plus 2i is 3i, 3a 3 plus 6i, right? 6i minus 6, that must be equal to 0. It implies I is equal to 1 ampere. Correct? The current is going to be 1 ampere. So as the taken direction is from A to B here, this is what the assumed direction. I am getting the positive here. So that's the reason why the current must be flowing from point A to point B through E. So option D is the right answer. Option D is the right answer for this one. Next problem. Okay, the figure below shows the currents in a part of electric circuit. The current I is the question, right? See, for this I need to use the Kirchhoff's current rule. Incoming current must be is equal to outgoing current. Okay, so for this, by according to that, the 2 ampere, this is the node here. This is the node. 2 ampere is coming. Even 2 ampere is also coming here. So it must be 4 ampere current because they are going to be added. Incoming current must be equal to outgoing current. So now again here is a junction again. So here 1 ampere is going here, and here how much it must be? 4 minus 1 is 3 ampere current must be flowing like this. Okay, again it is a node here. 1.3 ampere current is going like this. So 3 minus 1.3 is going to be how much? 1.7 ampere current. So that's the reason why option A is the right answer. 1.7 ampere current is flowing. I. Go to the next problem. In the circuit shown, the potential difference between X and Y will be is the question, right? See, X and Y, it is nothing but the open circuit. Correct? Open circuit. As it is an open circuit, there is no flow of the electric current through that. Correct? So the potential difference across the resistor V is going to be 0. Even here is this also. Let me take this plus and minus here. So this is also going to be how much? 0 itself. V is going to be 0. So that's the reason why the potential drop. So the equivalent circuit will be like this. So this is what the 120 volt, and this is what the points X and Y. So that's the reason why the same potential of 120 volt will be dropped across X and Y. So that's the reason why 120 volt is the right answer for this particular question. Okay, so I will upload some more problems on current electricity and upcoming chapters of class 12 syllabus as well. Please kindly like our channel, like this video, and comment if you have any doubts, and share as much as possible to your friends as well as colleagues, and do subscribe to our channel. Thank you very much for watching, and wish you all the best for examination. Stay home, stay safe. Okay, so enjoy the learning. Thank you.